Hi there, this is the review video of the Unit 4 test on circle theorems and constructions, and it's the test with 2 asterisks. And remember that to be able to do a retest or a point recovery, that you have to fill out the test correction form and turn that in at the time. And it will help you be more successful on your retest or point recovery also. That's to benefit you. So getting started, we are looking at the diagram for numbers 1 through 3, and the number 1 asks which of the following is a secant. So in the following, you just have to look and see what these lines are, and I know first off that a secant is actually a line, not a line segment. So right off the bat, I can eliminate B and C. And then at this point, I have to say, okay, GI is actually a tangent line. And EF, line EF, is going to be my secant, because the definition of a secant is a line that intersects the circle at 2 points. And then moving forward, it says which of the following is a tangent, and we kind of discussed this up in number 1, and so we know that that is line GI. It's a tangent because it only meets at the point of tangency H and intersects only once with the circle. The next one says in the diagram above, segment AB is best described as, and it's a segment, so AB, and it ends up being a line segment that's endpoints are on the circle, and that is the true definition of a chord. So segment AB is a chord. Number 4 talks about the central angle. So the first thing that you need to do is you need to actually draw a central angle. And even though my circle does not look like it, the central angle has the vertex at the center, and it says that the measure of that angle is 83 degrees, and so I know by my formulas that for a central angle, the measure of the angle is equal to the measure of the arc. So I know that the two are 83 degrees. Now, to find the major arc, I have to take 360 and subtract 83 from 360. And so the answer to that is 277. Number 5, it asks you to find the measure of angle TVU. And so I went ahead and highlighted angle TVU, and the vertex is on the circle, so then I know that the measure of the angle is equal to the arc divided by 2. So the measure of the angle is equal to 60 divided by 2, which is 30. Number 6, it says the measure of QSR, or QRS. So I highlighted that, and I realized from the highlighting, hey, I know that the vertex is on the circle, and so it's arc divided by 2, and I know that it's the intercepted arc divided by 2. So I don't know that, but I know that the other major arc is 200, so I take 360 minus that, and I'm left with 160 degrees, so the measure of the angle is equal to 160 divided by 2, which is 80. Number 7. First thing I know is that DG and EF are diameters. So it tells me a little bit about what I have going on here. And so if I'm using DG as the diameter, I know that this is 90 degrees. And I know it's going to add up to be 180. So I add those two together, which is 136, and I subtract it from 180, so that's 44 degrees. Same situation here. This is 44 degrees. And then I can find this particular measure by adding 20 plus 44 and subtracting that from 180, so I do believe that that is 116 degrees. So at this point, I can just add up what the arcs are. And in this case, I think there were 2 answers, and both were counted as correct. This is equal to 136 degrees, which is exactly what I want, so A would be correct. And then FJ is 20 plus 44 plus 46 is equal to 110, so that's not correct. EG is 90 plus 46, which is 136, and DF is 90 plus 44, which is 134. So my 2 correct answers, and either one was accepted, is either A or C. Okay, and then this one is what is a measure of the major arc, and we actually changed this to say minor arc. Okay, and so I did accept both the answers though, major or minor, and we'll talk about that in a second. So first thing I notice here is that I don't know what this measure is, but I do know that that's x degrees. So I take 360 minus x to be the major arc there. Then I know my vertex is outside, so measure of the angle is equal to the difference divided by 2. So the measure of the angle is equal to 360 minus x divided by 2. I multiply both sides by 2. 130 is equal to 360 minus 2x. And then I subtract 360. Negative 230 is equal to negative 2x divided by negative 2. And x is equal to 115. C is your answer there. Now, if we also accepted, in this version, we accepted the fact that it did say major arc, so if you did the major arc, it would just be 360 minus x, which is 115, and so that's 245 degrees. We accepted either C or D there. Okay, the next one is, it says solve for x, and I know that this is my angle that's indicated by 2x plus 5. And this is the arc that it intercepts, and this is a diameter indicated by the fact that it goes through the center of the circle. So I know that that arc is 180 degrees because it splits it in two. And since the vertex is on the circle, the measure of the angle is equal to arc divided by 2. So the measure of angle is equal to 180 divided by 2, which is 90 degrees. And then I set that equal to 2x plus 5 and solve. 85 is equal to 2x, and then I divide by 2. And so x is equal to 42.5. Number 10, you are asked to find the measure of angle JVM, but you are not given the arcs there to find the measure of JVM because it is inside the circle, so the measure of the angle is equal to the sum of the arc that it intercepts and its vertical angle interception. But I do see here that I can find this angle here, and then if I know that angle, those two angles together have to be 180. So I can use this formula to find this angle. So the measure of the angle is equal to 130 plus 70 divided by 2. So that is equal to 200 divided by 2, so that angle is 100 degrees. And then to find this one, I take 180 minus 100 degrees, and that's equal to 80 degrees. Number 11, it says what is the measure of angle ACB? And this is a central angle because the vertex is in the center. I know that this angle ADB is an inscribed angle, and the vertex is on the circle. So the measure of the angle is equal to the arc divided by 2. So 60 is equal to arc divided by 2. And so I multiply both sides by 2, and 120 is equal to the arc. And then from there, I know the relationship of the central angle is the measure of the angle is equal to measure of the arc. So the measure of the central angle is 120 degrees. The next one, number 12, it says you're constructing a circumscribed circle, and we know that a circumscribed circle is one that goes on the outside of the triangle JKL. And we know that circumscribed circles, you need perpendicular bisectors, so the only correct answer here is D. And 2, this was something that we did in class, and we actually constructed these, and you know that I refreshed your memory and said, please make sure that you know the steps to find how to construct these circles. Number 13 is a circle with two chords that intersect inside the circle, so it's part times part is equal to part times part. And so I have 12 times 5 is equal to 3x times 5x. So 60 is equal to 15x squared, because x times x is x squared, and divided by 15. And x squared is equal to 4, and then take the square root, and x is equal to 2. Number 14, I have a tangent and a secant. So the formula here, tangent squared is equal to outside times the whole. So 24 squared is equal to outside times the whole, which is 18 plus x. And then I take 24 squared, and I will need a calculator for this. 24 squared is equal to 576. And then 18 times 18 is 324 plus 18x. And then I take 576 minus 324, and I'm left with 252 is equal to 18x, and then I divide both sides by 18, and I'm left with x is equal to 14. The last one, number 15, this particular one was the construction of the tangents to a circle. And so we know that when we're constructing tangents to a circle, if both tangents have the same endpoint outside the circle, that the two tangents are congruent to each other. So that's the first thing I know. In the construction, I'm constructing a perpendicular bisector, so I know that segment CM is congruent to ME because it's bisecting segment CE. And I also know that in any circle, the radius is going to be congruent to any other radius of that circle. I also know that the radius and the tangent form a right angle. So those are things that I know just from my construction. And here it says CD is perpendicular to DE, and I know that to be true because it's a radius and a tangent. Let's see, DE is not congruent to CE. DE is actually congruent to FE, so that's not true. I know that MC is congruent to EM, so that's true. And then DC is a radius, and so is CF, so they're congruent. So the correct answer there is B. And hopefully that will help you.